It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 292. Let f be a twice differentiable function, but the graph of f has no point of inflection. If f of -1 is equal to f prime -1 is equal to -2, and f double prime -1 is equal to 1, which of the following could not be the value of f of 0? Using these informations right here, let's draw the graph of f roughly. Here we have x-axis. Here we have y-axis. Let's say this is y-axis. So let's say this value is -1, this value is 2. So graph passes through -1, 2, right? Here, f prime -1 is equal to -2. That means slope of tangent line at this point is -2. Function has to decrease, right? And when x is -1, second derivative is +1, which means the graph of f is concave up, right? Decreasing, concave up. So roughly it could be like that, right? So let's say this is f of x. And here we have tangent line, like that. Slope of this tangent line is -2. Okay. When function f is concave up, tangent line is always underestimate the function f of x, right? This linear approximation is always underestimate. Okay, what if f is concave down, like this? Then this tangent line or linear approximation is always overestimate, right? Does that make sense? Let's say this value is a, right? If we want to approximate the function f of x at this point right here, the actual function value is right here, but using this tangent line, it will give us this value right here, right? So this approximation is overestimated. Does that make sense? Okay, so let's erase all this. So when function is concave up, linear approximation is underestimate. When function is concave down, linear approximation is always overestimated. So far so good? Okay, so which of the following could not be the value of f of 0? This value, right? f of 0. When we use this tangent line, this tangent line has to be less than the function value, right? Well, reverse, this function value when x is equal to 0 must be greater than this value, right? Does that make sense? So let's find the equation of this tangent line. Here, slope is -2 and this point is -1, 2, right? So using point slope form, y minus y1 is equal to slope x minus x1, so x plus 1, right? So y minus 2 is equal to -2x minus 2. So substitute 0 for x, right? Then what is y? Y minus 2 is equal to -2, so y is equal to 0, right? Well, actually this value is equal to 0. Does that make sense? So f of 0, which is this value right here, must be greater than 0, right? It could be 1, it could be 2, it could be 3, but it cannot be 0 because this function value must be greater than 0, right? So the answer must be A. Does that make sense?